Okay, ladies and gentlemen, good morning slash good afternoon, depending on which hour of the day it is. As you can see, I'm not here today. Baby's sick, so hopefully she continues to heal and be wonderful. But in my absence, we still got learn to do because, as you all know, trimester's going to end soon. So, lesson 3.6, get that note sheet out. Let's get ready. Just a note, I'm going to be moving through this pretty quickly. So please do not hesitate. Raise your hand if you need to pause. The substitute will, I'm sure, gladly click the pause button and let everybody get caught up. So that said, let's get at it. We were talking about proportional and non-proportional relationships. So you're going to see how this kind of adds directly on what we talked about yesterday, which was direct variation. And then remember, this is any equation in the form of y equals kx. And we said that k was the same as m, and of course m is the slope. Okay, so y equals kx, y equals mx, all of this is just direct variation. We're going to add on to that with now proportional relationships. When you're looking at your note sheet, we're going to start with this half on the left, talking about proportional relationships. And each slide will kind of click through all the different chunks. First chunk, proportional relationships. The other name for proportional relationship is, wait for it, direct variation. So, proportional relationships are the exact same thing as yesterday. It's just another name, probably a more accurate name or certainly a more practical name. And we'll kind of see why that is as we go through. So, just as with direct variation, then, it passes through the origin. We're going to kind of do a Blue's Clues thing here. I'll pause and you guys can say it. It's up to you, but that's the idea. Everything passes through the origin, the point 0, 0. The equation still going to be y equals kx or y equals mx, whichever works at this point. Again, it's the same as direct variation, so it's going to work the same way. But here's what's neat about this, and we didn't talk about this when we were talking about, direct variation, was that we have this ratio of y over x, or y divided by x. That is the slope. Y divided by x is going to be the slope of any of these proportional relationships. And so that's always going to be the same too. So you can take any y divided by its x and you're going to get the slope. So here's why that works, just real quick. We start off with y equals kx, trying to get k by itself, which would be the slope. So we'll divide both sides by x. That gives us y over x equals k. And again, that means y over x equals m, because we know that k is the same as m. So that's just kind of how you can see y divided by x is always going to be that constant of variation, that constant of proportionality, or that slope. Remember, we said it has three names. Whoa. So, two things we have to do next are, one, find the equation by graphing. So we'll start with how to graph it. And we're going to start with this y equals negative 3x. Just like we did yesterday, start at the origin. Okay, so here's my point at the origin, and my slope is negative 3 over 1, so I go down 1, 2, 3 over 1, get my second point, connect the dots, and there's my line. Probably a good place to pause if you need to get that line down. So now that we've graphed another direct variation, which we're now calling a proportional relationship, we need to also then get the equation from the graph. So take a minute and copy down this graph. You'll see I've got the point 0, 0 and 1, 2, 3, 1. Okay, 0, 0, 3, 1. Plot those 2 points, connect the dots. Once everybody's got that, continue on. Pause. You've all got the line. Now we need to figure out the equation. And again, y equals kx is going to be our equation. We need a k, we need an m. So we start here at this origin. Up 1 over 1, 2, 3. So that means our slope is 1 over 3, or 1/3. That gives us the equation y equals 1/3 x. That's all there is to it. Okay, find 2 points, find the slope between those 2 points, plug it into the equation y equals kx or y equals mx. Okay, pause if you need to, ready to move on. Next up, we're going to find the equation using the table. Now again, dealing with y equals kx, the only thing we really need to figure out is the slope. So when we're talking about our steps, step 1 is to just find the slope, m or k, whatever we're calling it at this point. Now, because we're dealing with proportionality and proportional relationships, we have a new way to find the slope. And if you look at the top of your notes, remember how we talked about how the slope was going to be y over x? So we can find the slope really easily with these by just going y divided by x. And I like to look at this value because what's 5 divided by 1? It's 5. Now, that's the slope. It's 5. But remember, we can also find the rate of change because we know it's going to be a linear relationship. So change in y plus 5 plus 5. Okay, change of y is 5. Change of x is 1. So we get 5 over 1, same deal. But we have a nice little shortcut here with this divide y by x. Once we found the slope, plug the slope into y equals kx. Boom, done. We end up with y equals 5x, just like that. Okay, find the slope, plug it in. Boom. Pause if you need to. Next up, word problems. Okay, again, don't freak out. Start off by identifying your variables in your questions and then do what it says. Okay, so first thing it's asking, Marco is a personal trainer at a gym. In addition to his salary, he gets a bonus for every client he sees. Write an equation to describe this relationship. So here's what we're looking at. We got to write the equation, and then it also asks you to use this equation to predict the amount of Marco's bonus if he sees 8 clients. So those are the two things we're trying to do, and the first one is, of course, find the equation. Before we can do that, identify the variables. So the x's are going to be on top, y's are going to be on the bottom, because the amount of money he gets depends on the number of clients that he gets. So to get that slope, I'm going to use the m equals y divided by x, that little trick. You can count up and you can see, okay, this is plus 45, plus 45, plus 45, so on. But again, I take a y divided by an x, 45 divided by 1, 45. Nice little trick. Once I've got my slope, plug it in, y equals 45x. Once I've got that, I've done part A. Now it's time for part B. Use the equation to predict if he has 8 clients. Plug that 8 in for x. I get y equals 45 times 8, which comes out to y equals 360. What this means in context, Marco will make $360 if he sees 8 clients. And that's what I'm looking for. And again, there will probably be a point where you need to explain what that value means, so be ready to do that. Pause if you need to, rewind if that was too quick. That's the beauty of these videos, okay? Make this fit for you, but if we're all ready, let's move forward. Done with proportional. Now it's time to move on to non-proportional. So now we're looking at the right half of your sheet. Non-proportional do not pass through the point 0, 0, or the origin. Okay, so proportional passes through it, non-proportional does not pass through it. Since it doesn't pass through the origin, that means that the ratio y over x is going to be different for each pair. And if it's different for each pair, it can't be a constant rate of change. And if it's not a constant rate of change, that means it's also not our slope. So the y over x trick doesn't work. That's why I kind of kept talking about still using that rate of change idea, because it only works for proportional. It doesn't work for non-proportional. For finding the equation by graphing, we're going to do this very similar to what we did before, except now we've got something different, because we see this y equals negative 3x plus 1. That looks a whole lot like y equals mx plus b, because it is. That's slope-intercept form. Okay, make sure you write that down somewhere. It's going to become really important in chapter 4, but we're going to already start seeing it right now. So we have y equals mx plus b. We have this right here is our slope, and then this is going to be our starting point. Okay, we're going to treat this like we did the origin before, except now instead of starting at the origin, we're going to start at this y-intercept, which is at positive 1. So there's going to be our first point right here, positive 1. Now that we've got that starting point, though, we do just like we did before. Take our slope, negative 3 over 1, down 1, 2, 3 over 1, and we get our next point. Okay, we've got 2 points, connect the dots, everybody wins. We draw a nice straight line, and there's our graph from the equation. Start from here at our starting point, y equals 1, 0, and x equals 0, and then count down with our slope. Next up after that, we have to find the equation from the graph. So again, take a moment, plot these 2 points and connect the dots. The points are at the y-intercept of 0, negative 2, and then the point 1, 1. Plot those 2 points, connect the dots, and form your line. and then we have to make the equation from it. Now, again, we need two things. We need an m, the slope, and we need a b. We can find the b real easily by looking at the graph, saying, oh, it crosses at -2, so that means b is -2. And then I'm going to count up 1, 2, 3 over 1. That means my slope is 3 over 1. So that lets me know my slope is +3. Y-intercept of -2. Oh, there's my directions right there. You can read through those. And again, pause if at any point you need to copy that down. But again, I found my y-intercept. Start here, count up and over. I get the equation y equals 3x minus 2. Okay, I'll pause if you guys need it. Next up, we've got tables again. Okay, we're going to get the equation from the table. Now, steps to follow, things to make note of. We need to find that starting point first. Again, when we were doing it with the proportional, the starting point was always 0, 0. Now we got to find the y-intercept. But remember, how do we find the y-intercept? That's when x equals 0. And look, x equals 0, y equals 6. So there's our y-intercept. It's 6. Okay, when y is 6, that's our y-intercept. So the next thing we got to do is find the slope. Now, not dealing with proportional relationships, that little division trick I was showing you earlier is not going to work, but we still have our trusty dusty find the change in y over the change in x. How much does y change? 6 plus 3 is 9, 9 plus 3 is 12, so y is changing by 3. X is obviously changing by 1, so I have a rate of change of 3 over 1, or just 3. So now I've got my starting point 6, my y-intercept, and my rate of change is 3. Plug those both in, so y equals mx plus b. M is 3, b is 6. That's all I need. I should end up with a nice y equals 3x plus 6. And again, I'm moving fast, so pause if you need to, rewind if you need to. Take your time and make sure everybody's at least close to on pace with this. All right, last but not least, one more word problem. And again, don't freak out. Just identify the variables and then what the question is. That's the best place to start, and everything kind of falls in place from there. So Pam makes and sells bracelets. Each bracelet costs $5, and if you want to add beads to that bracelet, it's 25 cents for each bead. So again, write the equation to describe this relationship, then use this equation to predict the amount if someone buys a bracelet with 10 beads. X is going to be beads, Y is going to be price, because the price depends on the number of beads. Okay, that's always just a good question to ask yourself. So in order to find the equation, I'm just going to jump right into the table. Okay, I look right at the table, figure out what my starting point is and what my slope is. So my starting point is going to be 0, 5, because that's when the x equals 0. That's my y-intercept. And my rate of change, I can really get it from the problem. Every bead makes it go up by 25 cents. But again, how much does it go up from here to here? 25 cents. And from here to here, 25 cents. And from here to here, 25 cents. And from here to here, 25 cents. It goes up by 25 cents each. So I know M, I know B, I can plug them in. Y equals 0.25x plus, 0.25x plus 5. You'll notice I'm using decimals. Why am I using decimals? Because we're dealing with money, and it makes sense to use decimals with money. Usually I know I like fractions, but this time I think it makes more sense to use decimals. I've got part A complete. I found my equation. Now it's time to figure out how much if I have 10 beads. So I'm going to plug 10 in for x. Plug it into my calculator or use my head. I'll get y equals 7.50. Or in other words, $7.50 to purchase a bracelet with 10 beads on it. That's it, ladies and gentlemen. Those are the notes. Like I said, I know I went through fast, but remember, you can always pause, rewind, ask nicely. I'm sure the sub will certainly accommodate you in that regard. And then also this video is available on Schoology. In the notes section, it'll be labeled as section 3.6 notes video. So you'll be able to click on the link. It'll take you right to it on YouTube. Everything you could ever dream of. Work with a partner on this so that you guys can kind of use each other as a resource since I'm not there. Should put us in a good position so that on Monday when we come back, you've done the homework. I'll be able to go over it, answer questions, and we'll be ready to still take the quiz so that we don't lose any exam review days. Love you guys. Thanks for paying attention. I'm out of time. You guys have a wonderful day, and I'll see you on Monday. Have a great weekend.